By now you've already heard that these little mini quads are about the most fun you can have with your pants still on, and they are. These things are incredibly durable, just a lot of fun to fly, FPV, just super little machines. But a lot of guys have showed you how to take all of these parts and end up with something like this, but they only show you how to put the frame together. And I want to focus on the electrical part and then give you some tips that I've picked up after I've got about 200 hours on this little quad, and I decided to build another one and we'll document it. These tips are going to help you save money, they're going to help you save downtime, and just improve your overall experience. So stay with me. Alright, the first thing I'd like to caution you against is overspending like I did. These things, as I said, are just super durable. And so when I bought mine, they come all the way from Australia. I live in the United States, and so I ordered a lot of extra parts. In fact, I ordered probably close to $150 worth of extra parts, extra arms, etc. Don't do that. You don't need to. In hindsight, these things are just, you will never break these. If you break one of these arms, you have bigger problems than just the arm. You will never break it. You will never break the frame. I've hit trees, I've hit curbs, I've run into my car, I've lost power at over 100 feet. This thing's tumbled to the ground, and I've never broken anything except these tiny little plastic screws which are designed to break. So if you're going to buy extra parts, the only thing I would say buy is a crash kit. They're very inexpensive. They're about $8 each. Grab yourself 2 of them, and that'll give you a pack full of these little plastic bolts that typically break usually right here in the front. I usually break those 2 when you slam into something hard, and if you drop it from really high, you might break 3 or 4 of them along the top, and that's it. In the crash kit you get an extra one of these posts, but I have never broken one of those, and I have slammed into some stuff at pretty high velocity, so I wouldn't worry too much about those. Just get some extra bolts and you'll be good. Alright, I know everybody wants to jump right into bolting everything together, but before we do that, I learned an important lesson right away. First of all, the battery lead. You want to cut this down to a reasonable length. If you leave it hanging out there, all of your batteries come with a long lead on them already, and so if you got double this length, the props are going to end up hitting it, which is what happened to me. The other thing that I learned, and I had to buy a new power distribution board because of this one in fact, when we solder these leads to these rear pads, they're kind of hanging out there. And when we hit something with the rear of it, you got to remember, anything sticking beyond the boundaries of your frame is probably going to get broken or ripped off at some point. So try to minimize the stuff hanging out there. And if you do it right, the only thing remaining is going to be your battery lead hanging out the back here. If we solder it directly according to the instructions, when we hit on the rear, and you will, it's going to rip your power leads off. And of course, that's you're down right away. You got to head back to the shop to solder them back on. But the way these power distribution boards are built, these are foil pads, and when these leads rip off, they generally take these foil pads off as well. And then you've got a real problem. In fact, that's what happened on mine. I landed on the rear, the battery lead ripped off, took the foil pads off, and so I had to improvise and solder it to the inner pads, the 2 that you see right here. Now that's a plan, it works, but try to avoid all that pain and avoid having to buy another power distribution board. And the way I do it, this time I'm going to take my power leads, feed them up through the bottom, there's some little holes there, and then I'm going to solder them on from the side, as you see there. And that way, no matter how many times I hit this lead, it's not going to stress those foil pads, not going to rip them off. I got all the strain relief I need. I will never rip those off. So do that first, and that'll save you about $16 plus shipping from Australia. So that's my first tip. Let's see what else we got up our sleeves. Alright, we got that soldered on there. Now, the next part, we're going to start bolting this thing together at some point, but we're also going to have to start soldering to all these little pads that you see here. We're going to be using all of these. For example, your video is going to be coming out back here on this side. Your ESCs are going to be soldered here. We're going to be using this, we're going to be using all of these little pads. So now, while it's exposed, now's the time to go ahead and tin all these pads, and it'll make the assembly later just so much easier and neater. So let's go ahead and tin the pads. Alright, once we've got everything tinned and ready, go ahead. It's time to start bolting everything together. I'm not going to cover this in detail. There's too many other videos that show how to do that. So put your arms on, put the bottom plate on, and let's move to the next step. Alright, that should take about 10 minutes. The next thing we want to do is go ahead and put our motors on there. Now, the only tip I have here is use these little metric screws that come with your motor. And before you put them in, there's a lot of vibration on these little machines. Go ahead and put some thread locker onto the thread, just a single drop, and that way you won't have to constantly be tightening up these little screws that do tend to vibrate loose if you don't use thread locker. So let's put those on there. Alright, looking more and more like a quad. Alright, since we're talking about motors real quick, the first thing you want to do is these nuts, or whatever you call these things, these aerodynamic things, you want to get rid of those. They're too heavy and they tend to fly off during flight, which usually results in a disaster. Instead, go to Home Depot or Lowe's or some hardware store and get yourself some metric 5 by 0.8, and these are the lock nuts. They're the ones with the nylon bushing on the top. So when we put these things on there to lock that propeller on, we know positively they're going to be staying there. Anyway, let's talk about the ESCs. Now, we might be tempted, and I've seen guys do this, to go ahead and put your ESCs on there and then use these traditional bullet connectors. But when you think about it, that's probably not a smart thing to do. We're going to be introducing, if you count them up, there's 36 possible points of failure, 9 per arm, and we're just going to avoid that altogether. So instead, what I'd like you to do, get your single edge razor blade and cut away on the ESCs so we have access and we can take these wires off with our soldering iron. So let's go ahead and do that. Alright, don't completely remove the plastic. Instead, just cut a slice down each side of it, so that way you can kind of fold this thing back a little bit, take a piece of black tape, and just tape it back out of your way. Because when we're finished removing these and putting the new wires on there, we're going to fold that back and we're going to insulate it against moisture to protect it. So that's what we're after. Okay, after you get the wires removed from those ESCs, go ahead and sacrifice some zip ties. Tie down your ESCs about where you want them. Get them as far inboard as you can get them, and then tie them down firmly. And that way, when we start soldering, they're not going to be moving around on us. Now, obviously the motor wires are too long. So what we're going to do, we're going to measure. You know they have to go to these 3 contacts. So just measure right up where it meets up with the heat sink. That's where we're going to cut these wires, and that'll give us plenty of slack to move things around if we have to. So go ahead and cut your wires, tin them, and let's begin soldering. Alright, when you get done, it should look something like this. And now what I've done is I've soldered them all identical. So wire 1 to position 1, 2 to 2, 3 to 3. Now what that guarantees is that half of the motors are going to be turning the wrong way at some point. But there are things like servo testers and oscilloscopes, and there's ways to figure out how to do it right the first time, but it takes a lot of time. Just if you do it this way, when you calibrate your motors, you're going to find 2 of them turning the wrong way, and you'll have to redo 4 solder joints. Not a big deal. It'll take like 2 minutes. Okay, while you're there, go ahead and take your servo cables, wrap them around the ESC, and just use some black tape and tape it out of your way, because next we're going to be soldering these power wires. And if you don't tape these servo cables out of your way, you're probably, like I did, going to end up burning one with a soldering iron, and they're just going to get in the way. Now you'll notice these come with connectors. Again, these are points of failure. We're not going to be using them. We're just going to position these above these 2 leads, clearly marked plus and minus. We're going to cut these to exactly the length we want, and we're going to solder them in place. So let's go ahead and do that. Alright, that should take you about 5 minutes. Next thing we're going to move on to before our power distribution board gets too cluttered is let's work from both ends. First, we're going to go ahead and put in our camera. Now, your camera, I use a PZ0420, probably the most common camera available, very cheap. I think on eBay they're about 50 bucks. I personally like the 2.8 millimeter lens because it gives the best mix of distance and proximity. I tried the 3.6, but it was just too narrow of a field. Anyway, when you look at the back of this, you're going to want to remove this outer frame. Just take your dikes or your cutters and cut this outer part off all the way around. Just be careful. And we're not going to need that outer frame. We're going to reduce the diameter of the board because we're going to mount through those holes. Unless you're anal retentive and you really care about every single detail of what's appearing, you can get rid of this thing. We won't be needing it. And this entire cord, I would strip it down. You're going to need these wires, so I'm going to strip it down and give myself about 4 inches of wire for right now. We'll work from there. Alright, you get done mounting your camera, and that little shock absorbing mount should look something like this. Just a little tip here. Use some thread locker on these, because if you don't, you're going to find these little screws vibrate loose. Even though it's a nylon little miniature screw in there, these will vibrate off and you'll lose them. So a little bit of thread locker prevents that. The other thing I want you to pay attention to is how this is oriented. If you use a PZ0420 camera, it goes in like this. The power lead and the video lead are on this side, so they'll be at the 3 o'clock position. That way you can solder everything directly onto the board itself, or, as I'm going to do, I like to know how much power I have left in the battery, so I'm going to put one of these Hobby King Super Simple OSDs in there. This tells me how much is left of my battery, which is kind of a nice thing to know. When I get down to about 10.2, these things tend to fall out of the sky without warning. So I want to land safely before that. I'm just going to mount it directly. The video is going to feed directly through this. It's going to go back out of here and directly into the board where it says video. Easy to do. Just slide it in there. Anyway, let's go ahead and get that done. Alright, we got that OSD in there. I'm going to leave it a little bit loose because we're going to zip tie it to the top frame once we put it on there. In the meantime, I'm going to push it off out of the way, and we're going to move to the rear and look at the video. Now, when we put our video in, I see everybody, and I did it myself, we put in the video transmitter like this because it's convenient and it lets the antenna stick right out the back here. And I can tell you there's a big problem with this because I broke 2 transmitters. Now remember, I told you anything sticking beyond the perimeter of the frame will eventually get broken off. And that's what happens here. When you slam onto the ground and it hits this direct connection onto the transmitter breaks your circuit board. And I broke 2 of them right across there. When you break these, they're about $70 each. So we don't want to do that. So instead, what I've come up with and what Blackout recommends is that we mount it backwards. A couple of advantages to this. First of all, our electrical connectors are on the very back, so we can keep our leads very short because there's our positive, negative, and video. So our leads are only a couple of inches or an inch even. But what happens is it leaves our antenna up here. But that's not a problem because on the Blackout site there's a link to buy these little 4-inch extensions. And when we buy that extension, we get the top frame, we mount it in the hole that they pre-drilled, and then the extension sticks down the side and it allows us to connect on the front to our transmitter. So what a great idea. When we crash, there's no stress on our transmitter. At worst, we break this part off, which is $4. So big deal, right? It's a lot better than $70 for one of these. Now, I don't know what kind of transmitter you're going to be using. There's a wide variety of them. There's 2.4s, 1.3s. Here's one of the brand new 2.4s from Immersion, but it doesn't matter. They all have that same structural weakness. We don't want to put any stress on this because once we break that, we've broken some very expensive transmitters. One of the most expensive parts of the entire quad. So spend $4, get that cable, and let's do it this way. Let's mount this up. I'm going to put the plug in, solder the leads on, and we're going to mount this vertically just like this. And I'm going to zip tie it to the top frame just as I will this OSD. Fellas, we're almost home. Okay, the next is the flight controller. This happens to be a CC3D. I also have a NAS 32, but anyway, they all go on the same way, arrow pointing towards the front. And once we get that in there, put some nuts on there, then we'll talk about routing wires because that's another tip and that's a way to save some propellers. All right, fellas, this next part is kind of important. I've made many mistakes on this. And you know you're wrong when you try to fly your quad the first time and it keeps flipping over and breaking propellers. And I've broken a lot of them by making this mistake. So try to remember the board that you're looking at. That's probably the key. So we're using a CC3D here. There's no industry standard for numbering our motors. So a CC3D happens to be 1, 2, 3, and 4. Now if you're using a NAS 32, it starts to get really confusing because then it's 1, 2, 3, 4. And if you're with the NASA, which will go on this quad, you're looking at 1, 2, 3, 4. So you see it's all different numbering systems. So if you pay attention here, like I usually fail to do, these are numbered very clearly on the header, 1 through 6. We can take up to 6 engines. So we got a CC3D. 1 will go on to the first one, and then of course 2, etc. Pay attention. Don't assume that everybody numbers the same as NASA, which is I think what we're all used to. So if you get it right now, you can avoid more than one broken propeller and a lot of frustration. All right, we got that checked and double checked, and I got everything tied down because when we start flying this, I don't want cables flying out there getting caught by the propeller. So that works. Next, we're going to move to the receiver. Now, I'm going to use a First Sky, an 8-channel, not because it's the best one, because it probably isn't, but it's the one I have. So it's awful big. I'm going to decase this thing because the circuit board inside is much, much smaller. That's what we're going to go with. All right, there we go. Not really a lot inside of that big case, but pretty delicate circuitry. So what I'm going to do is take some shrink wrap, I'm put it in there, and just to protect that circuitry in case I fly it on a morning where the grass is covered by dew. I'm not going to screw this up. So let's make that happen. Alright, there's what we're looking for. I marked on the outside, minus on the bottom, signals on the top, so later I don't have to peel off this to figure it out. The other thing, make sure before you start assembling everything that you've bound your receiver, whatever kind you're using, to your radio, because the button is going to be hidden beneath the circuit board. So getting in now is what you want to do. And then the final thing you want to do is most of these receivers you have to set the fail-safe while it's out. Again, after you've bound it, normally what will happen is you set the controls on your radio at the position you want your fail-safe to be, and then you'll push your set button again and it'll set your fail-safe. I learned this one the hard way, fellas. I had a flyaway. I forgot to set my fail-safe, and by default it maintains the last signal that it received. So if you're accelerating, if you hit the go button and it loses a signal, this thing will keep going. Luckily mine hit a pine tree before it got out of sight. So I recommend that you set all of your controls to 0, so if you ever lose a signal, it'll drop straight down to the ground and you won't lose an expensive quad. Anyway, let's put this together. Okay, I think by now you guys have got everything tied down with zip ties just like this. Nothing shakes around that's going to get thrown out into a propeller. The only thing really loose are our transmitter, which we're going to zip tie to the top plate when we get that on. And then we have these two little antennas right here that go to your receiver. Now, I ran into a couple problems with these. I had to buy an extra receiver because I just kind of dangled these out of the bottom and I lost connection one time, and that's really not a good thing. And the tips of these kept getting caught in the propellers because they kind of flop around in the wind. So it doesn't really work. Ideally, they should be oriented vertically. So the way I did that on my original quad is I got some tubing out of a ballpoint pen, and I ran those antennas up through that tubing, and then I just put some shrink wrap on the top there to kind of hold everything in place. And that's what we're going to do here. That's worked pretty good for me. Had to drill an extra hole in the top right about there so that tube can kind of fit down in there. Put a drop of crazy glue and it'll be just like the other one when we get some shrink wrap on the top of there. Other than that, let's go ahead and glue that in, feed the antennas through the tube, and let's put the top plate on. Alright, all we need to do now is a couple of cleanup details. By now you've already calibrated your flight controller, whichever one you decided to use, and you know the rotation of your engines. You probably noticed I had to reverse on engine number 2 and 4, I believe it was. I had to reverse the wires on those two. It took me 2 minutes. Now I don't just want to remove the zip tie and the tape. I want to make sure that those connections are protected. And in order to do that, I'm going to take some liquid tape. I'm going to smear it on there to insulate those, and then I'm going to fold the flap back so it looks good. And I put a fresh zip tie, cut off the edge, and that'll look like almost like professional did it. Well guys, at this point you're really done. You could take this thing out, put some props on it, and fly it. Everything's tied down, nothing's going anywhere, but there are a couple of options. First of all, you're going to get one of two different types of vibration absorbers. This is the old style, and these little rubber plugs tuck inside of those slots there. I don't use it. I found that when I did hit a tree, almost 100% of the time, this would disconnect and take my Mobius and fly off somewhere. Had a lot of trouble finding it. The new one, a lot higher quality. This is a very stiff. The screws go down inside of the posts, so this thing really is solidly locked on there. So solidly, in fact, that it almost does no vibration absorption whatsoever. But you know, these little quads, with these props, they don't put out that much vibration. So what I've done is I just take double-sided Velcro, and the Velcro itself is a vibration absorber, and I just stick it right there. And the quality of the video, I can't tell any difference if I'm using one of these fancy things or just using Velcro. It's a lot lower profile, it's not quite as top heavy, and you actually save some weight not having to carry these things. The other thing I've come up with, the final tip and probably most important one, is you don't want to lose these things. By now you figured out you got some serious money invested in your quad, and it'd be a shame to lose it. You know, you're flying it around in the woods somewhere and it gets in some thick ivy or deep grass and you can't remember exactly where it is because you got disoriented. Yeah, that happens to me all the time. I know it doesn't happen to you, but it happens to me. So what I've come up with is these are stick-and fines. You get them on, I got them off eBay. I think they're about $15. They come in a 2-pack. Very, very light. It weighs less than a penny. Got some 3M adhesive, and I will peel it off and I'll just stick it under the frame somewhere. So it's Bluetooth, as I said. If I get within 100 yards of it, I can use my iPad to locate it. Now you see I've named it Blackout 2, and as I move that coin-shaped thing back and forth, the icon will also change. And as you get closer to it, it shows you where it is. So it really is useful for finding your quad. If you don't know where it is, you can get within 100 yards, you can find it. Really useful tool, and for 15 bucks, fellas, that's cheap insurance. Anyway, there you go. There's your new quad. I hope some of the tips were useful. I told you these are the most fun you can have with your pants on, and I recommend when you do fly, my experience is, at least with the local police, they prefer that I keep my pants on. Anyway, fellas, thanks for your time.